Hey, good evening. This is what you saw there was a very interesting clip of the low-level jet trying to get started up. That was about 10 in the morning. This is about 6 in the morning. And you can see moisture off to the south, kind of like a hazy layer. And then 3 hours later, here it is. There's that low-level jet trying to get forming. It's that, you saw that gray stratus there just a second ago. That's the stratus up at about 1,000 or 2,000 feet. And above that, a little bit of cirrus. So that gave way to areas of thunderstorms all the way from Kansas, up along the Kansas-Oklahoma border, all the way down into central Oklahoma, and even into the Fort Worth area. So we'll be taking a look at that this evening here. And I'm sorry, I am losing my voice for one thing, but I am starting 1 hour early so I can do some Sunday family plans with the family. Come on, guys. Give me just a second. My voice is breaking up big time here. Okay, let's give that a shot here. This is the current analysis looking across Texas and Oklahoma. What's pretty cool is you can see a few fine lines here on the Amarillo radar. So that's some good evidence, maybe a cold front working through that area there. So if we actually look at the numbers here, this is bad data, that's bad data, the other data is good. One thing that you can see that's a little bit interesting, look at the dew point, the number in the lower left. We can see it goes from 29 here to 27 at Lubbock, up to 35 in Amarillo, and up to 40. So this is one way you can kind of find your air mass contrasts. So let's see, where's the driest air? It appears that's over the San Angelo area, maybe around Wink, up to Hobbs, to Carlsbad. So a good pool of dry air right there. This is air from the plateau regions of Mexico. And we can see the temperatures in that dry air mass are very warm. 81, 85, 85. So this is the dry sector. So in between that and conditions up in Colorado, there's a pretty strong difference here between temperature and moisture. So it looks like that that temperature starts falling off maybe around Lubbock, and then big time around Lubbock, Plainview, Amarillo, and then especially up near Guyman. So I guess we're going to go with maybe something like that for the leading edge of that cold front. We do want to try to keep that south, if at all possible. So this probably links into the system, kind of like that. Then where is the dry line? Well, we got to go to the south for that, into central Texas. And for this, look along that line right there. We go from 83 over 24 at Fort Stockton up to 83 over 61. Pretty good moisture there at Fort Hood. Moisture axis looks like it is roughly in that area right there, 61 to 62 dew points within that moisture axis. And this is not a good moisture axis. We've only had about 18 hours of return flow here, but it is definitely some moisture at least. So I'm going to go with that right here for a dry line. And another way to look at this is, can you support thunderstorms back here? Maybe not with 88 over 48. Can you support them out here? Yeah, you definitely can, 80 over 61. So you're going to want to put the dry line also where the air mass favors development of thunderstorms. So we could just take this area of storms here and extrapolate that southward. It looks like they're forming where we have dew points in the mid-50s. 60 here at Wichita Falls. So yeah, maybe I'll go with that. This is basically the functional dry line right here, and the storms are forming along that boundary. Okay, let's get into the standard chart sequence here. Oh yeah, I got the SPC storm reports, and you can see not a very busy day at all. Very quiet, just a few hailstorms here or there, mostly concentrated on central Oklahoma and just south of Wichita Falls here. And this is the temperature anomaly here, so this is showing you how warm or cold the air masses are compared to normal. So this is a very localized pool of cold air. So maybe this is kind of a mesoscale development here. Maybe its origins are from thunderstorms. Maybe from showers in the Central Plains there. I don't know. We would have to go back and look at some charts. It may connect into this area right here around Iowa, so maybe this is a modifying cold air mass. But in any case, the big picture, very warm in the central U.S., and we have to go out to the west coast to find cold air. And I'll put up the 500 millibar analysis for this morning at 12Z. And let me grab my throat spray here. And while you take a look at that, I'll take a look at the chat and see what we got going on. We've got Alexi checking in here, and Mark and Andrew, Brett Dean, 41 degrees there. David Holcomb, his voice is kind of wasted down there too. Down in New Braunfels, Texas. That's going to be just northeast of San Antonio there. Pretty close to Lockhart. That's got the best barbecue in Texas, in my opinion. Ryan Toomeys is here, and Ron Chalfant, Charles Skelly, Dwayne Ward is here. Mark Davis saying cloud lightning, 20-second delay there in Denton. Ryan seeing the big cells popping up in that area. Brett Dean is surprised or amused at the strong storms with hail, with low dew points and temperatures 61 degrees. Mike Estwick is here. Ryan is asking if Dallas is under the gun, and Mike Estwick says 47 in Denver there. Okay, we're going to go back down to Texas and Oklahoma in just a minute, but let's look at the dynamics a bit. Okay. Polar front jet from about the Tucson area up to Oklahoma City and then to Nashville. So we've got kind of a split flow pattern here. The northern split up in Canada here, the southern split down here. And do we have a subtropical jet? I don't really think so. I don't see any anomalous strong winds down in this area. Of course, the final say on that is at 200 millibars. So maybe I'll go up to 200 millibars and check that out. I'm going to go to Meteostar and bring up the heights and winds at 200 millibars, because I've been wondering about this for the past few days. And yeah, looks like we do have one. So you see it right there. Basically from Baja California across the Durango area to Del Rio, Beaumont, and New Orleans. And the reason I'm saying these cities in my head is because when I go back and look at other charts, I've got that list in my head. So I can kind of trace that same area here. And you can see the 500 millibar chart is not showing the subtropical jet. That's a high tropospheric feature. So this is another reason why you have to look at all the charts. And this can be very important, because these 200 millibar winds mean very strong bulk shears, especially if your winds down at the surface are not very veered. So that'll stretch out your hodograph and not necessarily give you curvature, but it will give you good separation between the low and upper tropospheric vectors, and that means long-lived cells. And that's how we get a lot of good hailers down in South Texas this time of year. Even if the curvature is not there, even if the mesolows are not there at the surface down in that area. Okay, here's a very cool chart. This is the water vapor imagery. And the predominant feature that we see here, well, not predominant, but one feature that caught my eye is this dry slot. So you see that wrapping in there across Amarillo. So this is drier mid-level air, wrapping up towards Wichita, then up towards Colby, and then around. So probably what we have up north, this is more cold core activity. And then the jet stream type activity a little bit further to the south down in this region here. Okay, let's do a quick thermal analysis and look for any fronts. And I think all we've got to go on, I think all we have is just this here. I think that's it. So you can see there's not a big push from Canada for this pool of cold air. It's a very localized feature there. Next system coming onto the California coast here. You can see that cold air advection right in that area, so cold front running right through that area. And where's the warm front? I don't know. I'm going to guess probably right there. Okay, let's look at the soundings because we do have a storm day. Let's check out what Norman had this morning. I'm going to back this up to 12Z. So how's our moisture looking at Norman this morning here? Well, we can take that lower moisture right there and read that down at the bottom, and we can see that's about 6 Celsius. That's about 41 Fahrenheit. This is a very poor moisture. And what kind of LCOs were we looking at this morning? Well, let's throw in some surface heating. I can see they got up to 77 degrees today. So 77 is about right there. So you can see there's no prospect for thunderstorms with this kind of sounding. And this is where air mass modification really becomes important, because the big change that we've had today has been the deepening and enriching of this moist layer right here. So that's probably come up quite a bit, and we can see dew points up in Oklahoma this afternoon, 58. So we have to modify this quite a bit. We have to bring the moisture all the way up to here. And then our temperature would be looking kind of like that. So that's a huge change to the bottom part of your sounding. So you may be wondering how to account for that. There's two good ways. One is to look at advection. So during the morning hours, you'll see that Norman has 40-degree dew points. Look to the south, down in Texas, and see what kind of moisture is coming northward. So you can adjust your sounding based on that. And the other method is to go to the forecast soundings. Let the models work it out. And there's nothing wrong with that. You can take those values that you're seeing with the model, and you can put that back into your sounding and modify it based on that. So let's see here. Let me show you the sounding there for Norman. So this is a model run from earlier today. So the high resolution rapid refresh forecast for 22Z. There it is right there. So you can basically take that moisture and read it off these green lines right here. And you can see we've got maybe pretty good depth of 8 to 9 grams per kilogram. And you can take that and take those values. 8 to 9 is going to be right around here. So you can modify your sounding based on that. Okay, let's move things along before we get too bogged down. We'll take a look at the dynamics. Dynamics for tonight looking like that. So you can see a bit of a shortwave trough coming across Oklahoma. Most of the lift focusing on eastern Oklahoma, central eastern Oklahoma, and North Texas. And this trough is moving very quickly eastward. So by dawn, it's going to be located out towards St. Louis, Jonesboro, Memphis. Okay, then we get a break tomorrow. The next system comes in for Tuesday night and Wednesday. And this will be a deeper trough. There's the polar front jet on Tuesday night. So storms appearing for Tuesday night and then probably again on Wednesday. There's the Wednesday panel for when we do the meteorology lab. So probably some storms there in Texas. Got to move quickly eastward, and then another wave coming in for the 2nd. This is on the weekend. And it looks like we're not going to start getting these troughs until Saturday or Sunday. And that's going to be mostly, I think, on the high plains here at first, because these troughs are rotating around like bicycle spokes, and mostly just affecting this area right here. We don't see that emerge into the I-35 area, until about Sunday. Sunday is when that happens, and then Monday we get a pretty good shot. There's Monday's panel. Looks pretty wet. Here comes another trough. You can see very good shortwave right there. Another shortwave coming in from the northwest. This may be a little bit of a northwest flow situation on Thursday the 6th. Yeah, look at that right there. Very, very meridional pattern here. Very high amplitude ridge. And then things start looking a little bit quieter for the southern plains, mostly focusing on this area around the 11th. Okay, I think we're probably about ready to just go ahead and head into the forecast. And we'll start out looking at the convective models. I've brought up the high-resolution rapid refresh model here. So there's our 23Z panel, the 0Z panel looking like that. And it's 0Z right now, so we can kind of validate this. And the model is thinking some thunderstorms in the Stroud-Muskogee area. Very weak in Texas, around Denton. How does that compare with current data? College of DuPage is a good site for just quick radar panels. So I'll go to Weather Analysis Tools and then Radar. I'll click on the 2 kilometer products and then on Radar. And we can see a pretty conspicuous difference here between the high resolution rapid refresh and this. So do you see the difference here? The activity is more widespread than what the models are depicting. So we've got a lot of activity from Muskogee all the way down to around Waco. And our model is going with that. So what are you going to do here? Are you going to use the model? That's a good question. You know, you could one option is you could stick with the most basic fields and kind of use it as a framework for your forecast for the rest of the evening. That's probably what I would do. So looking at the big scale picture, we see the main mesoscale low out west of Oklahoma City. And another trend that we see here is intensification of this line. See, we go from 0 to 1 to 2 to 3. So maybe that part of the line in the Red River region, maybe that's going to start filling in a little bit. So that's what I would be thinking there. And then towards 3 to 4Z, towards midnight, that'll move into Arkansas. So probably a good chance of thunderstorms in that region. And that'll persist pretty well overnight as that moves toward Memphis and Little Rock there. Okay. And we'll switch over to the GFS and look at our forecast. And I'm going to come back and give you a couple of more hints with that high-resolution rapid refresh model with the soundings. So let's get this out of the way real quick. Here's our low in Oklahoma City tonight. That's going to move quickly eastward. Then by the time we do the webcast, we're going to have the main low out over southern Illinois. So a bit of a weak cold front extending southwest into Texas, and then a warm front up into Ohio, kind of like that. Okay, where are we at? Let's see here. Okay, there we go. So there's that low pressure area. That'll keep moving eastward, and then our next system comes in from the west. Some very good cyclogenesis out over Colorado. So it looks like by the time we do the webcast tomorrow night, I think the front's going to be crossing the Rockies, maybe the deserts, kind of in that area. And then by the time we get up to Tuesday night for the webcast, that's coming out of the Rockies into Texas. And I think we're going to have maybe a warm front set up here. So depending on how much moisture there is, maybe a chance for severe in the Red River Valley. So I'm going to be looking for that possibility there. Looks like a squall line moving eastward overnight. System gradually moves eastward into the southeast U.S. later in the week. And then the next system moves in from the west. Cyclogenesis confined mostly to the Big Bend area, Texas, right there. And this looks like mostly isentropic lift, like overrunning, and upslope flow with that strong easterly component there. Okay, the other thing I was going to show you, let's go back to tonight's forecast here. So here's what the models have for Texas and Oklahoma tonight. And if I click on this panel here, I'm going to click on Paris, Texas for Tuesday maybe. And that'll bring up a sounding and a hodograph and some other good stuff to look at. And this will help us assess the severe weather potential. So one quick thing you can look at here is this graph for significant tornado parameter. And you can look at which values have the highest numbers, like which ones stand out the highest. And we can see CAPE as the main contributor. So we're looking for instability to really be the thing that's driving the activity tonight. Does that match up with what we have on the SCU-T? Yeah, it does. The moisture could be better. But we do get some CAPE. Some very marginal CAPE. And it's also it's suggesting the LCL is going to be kind of high due to the dry air. Storm relative helicity is going to be on the low side. And indeed the hodograph shows kind of a small area swept out. I'm going to call that kind of marginal there. And then the other factor is bulk wind difference, the bulk shear. And that appears to be a little bit on the low side too. So 0 through 6 kilometer shear looks to be about 40 knots there. Okay, then another example. Let's just go forward and look at the environment over Arkansas for midnight. I'm going to set this on Little Rock. So again, we look at the severe weather parameters, and we can see that the dominant factors here are CAPE and LCL. So our moisture here is a little bit better. And the sounding kind of bears that out. Relative humidity definitely looks a bit higher in that layer right there. And there's our instability. Parcel lift looks like that. There's our CAPE. That's going to be about 1,000 to 1,200 CAPE. So anyway, that's some stuff to look at. Yeah, just head over to pivotalweather.com and check that out. And they've got some cool charts. They've got all the convective models. So high resolution rapid refresh, the NAM, which is basically the WRF. And we've got a couple of other WRF cores here. Then of course we've got the global models. The climate forecast system, the European model, GFS, and the Canadian global model. Okay. 7:30, so I'm going to have to sign out for tonight and go hang out with the family. Hope you all have a good evening, and let me just take a quick look at the chat and see what else is going on here. Mark Davis says, tornado warning just came across for Denton. Yeah, we'll check that out before we go real quick. Let me bring up the Fort Worth radar. Looks like we do have a warning there for, looks like around the Tupelo area of Oklahoma. Let me bring up the cities here. Yeah, so just east of Ada. Possible tornadic storm right there. And we'll go down the line to Fort Worth and see what the storm looks like. And that'll close us out for tonight. Okay, so our data is coming in. And we can look at the warning while we're at it, and we can see radar indicated rotation. So that's good. We don't have a spotter reporting a serious problem just yet. Okay, there's our data. Probably what we've had is a little bit of a spin up here in this storm. We can see it doesn't really have the classic supercell signature. The reflectivity gradients are not particularly high. On this storm here, you can see some gradients right in that area. And that kind of clues you into where the updrafts are. Not seeing much of a gradient down here. But if I go back a few frames, yeah, it looks like this cell here had a pretty good gradient down in that part of the storm. Anyway, the velocity is the big story. Let's zoom in right here. This is around Justin in southwestern Denton County. And we'll run that forward. I'm trying to see what feature they're looking at. I think they may be looking at this right here. I'm seeing a bit of a very tight circulation. So this is about 32 outbound and 13 inbound. That's about 50 knots a shear. That's not huge. I'm going to put a marker there and look at the reflectivity. Looks like an embedded circulation right in that area right there. Spectrum width, yeah, that shows some high diversities in here, so that would certainly attract my attention a bit. And the other thing that we can do is go up into the higher tilts and see what those are showing. Okay, yeah, we can see here earlier, about 12 minutes ago, we had much better rotation down in this area here. So we were seeing roughly about 42 out and 20 in, kind of a tight mezzo. I'm going to put a dot right there. There you can check out the storm, and you can see that is kind of in this updraft area, kind of a rainy updraft. And I think on these last couple frames, I think the circulation is kind of broken up. Nope, actually there it is right there. I went down to 0.5 and checked it out, and there it is. I'm seeing 53 out and 21 in. Probably don't have this balanced too well. Let me fix that real quick. I'm going to set a vector of 220 at 15. Yeah, that's definitely better. Okay, so this is showing that circulation. And this is just west of Justin. And definitely an embedded circulation there, so this is going to be pretty difficult for spotters to keep track of, but definitely looks like something going on in that storm right there. And I'll give you a quick projection of the motion. Looks like that's heading towards the Denton area. But that's still about 12 miles out, so a lot could change between now and then. So fortunately, I think right now this is kind of over relatively open land. Okay, so anyway, I think that'll do it for tonight. I appreciate you all watching, and we'll see you tomorrow night. Take care.